All right, we're going to deal with some age dependency ratios. So this is a specific application of types of ratios. So you're going to be given kind of this chart here, right? We have all of this data here. And you'll notice that it's summarized on the right. So we've got 0 to 14, we call these children. Over 65, we call these oldies. And then this people in the middle, 15 to 64, we call these people the working class. Okay, so those are the workers. So we're going to answer some questions. Now, first thing, it's important that you can recognize where they got these numbers. So under 5 to 10 to 14, that's where we got the children. 15 to 19, all the way up to the 60 to 64, right? These are the workers. And then everybody else, these are the oldies. All right, don't tell my mom I call people that age oldies because she might be offended. All right, so you can do that. Now, are these exact values or estimates? Well, when we're looking at, this is from the U.S. Census, and you're like, oh, it's got to be exact. No, think about it. As soon as you fill out the census the next day, people are born and people die, right? That happens, it's called life. So these are estimates, right? They were maybe accurate at one point in time, but things change. What was the population according to this data? Well, here's the total, but I'm sorry, there's more than 306,000 people in the U.S., and you can see here it says number in thousands. This is where the fine print or the title of graphs really makes a difference. Thousands means 3 decimal places. So we're going to take this 306,110 that they give us, and we're going to add 3 more zeros. 306 million people, yeah, that makes a little bit more sense. But because all of these numbers, everything on this page is in thousands, that means everything has 3 more zeros at the end. So I really don't have to write them anywhere because they would cancel out every time because everything has 3 zeros in the end. Okay. So we are now going to calculate the ratio of under 15-year-olds to the total population. Okay? So we're looking under 15 to the total. Well, if you look back at your table there, you see that under 15 has 62,155 over the total, which is 306,110. Now, that's a huge fraction. It means nothing to me. But I can change that to a decimal, and I'm going to make it 0.203 because, you know, I can put that over 1. It's a little bit more meaningful if it's smaller. Now, let's think about this in part A. Part to part or part to whole? Well, look at your denominator. The denominator is everything. It's total. So this is part to whole. And if you remember, part to whole means we can write it as a percent. So 0.203 becomes 20.3%. And when I interpret the meaning of this ratio, that means 20.3% of the population is under 15. Boom. Okay? So that's where part to whole comes in nicely because now you can talk about things in terms of percentages, right? 20% of the population is less or is under 15. Okay. Now we're going to get into the child dependency ratio. So what this means is that when we talk about dependency ratios, people that don't work, the kids and the old people, they are dependent on the working class. So the child dependency ratio puts the children over the workers. So that's under 15 compared to the 15 to 64s. So the under 15, we know that that's 62,155, and the workers are 204,777. Again, it's a large fraction. It's hard to deal with. But I can change it to a decimal by dividing, and I get 0.304. Now, is this part to part or part to whole? Because once I answer that question, I can decide if I can write this as a percent. Well, child, that's part of the population. Workers, they are also part of the population. This is part to part, so my answer must be written as a decimal. So I will take my 0.304 and I'll put it over 1. Because remember, the top is the children, the bottom is the workers. So interpret the ratio. We have 0.304 children dependent on each worker. And you might say, well, that doesn't make much sense. It's 0.3 of a child. You can't have a part. Well, that's true. If you're like, well, I want to make the ratio, I want to interpret this a little bit better. Okay, well, think about 0.304 over 1. If I move this decimal 2 places, well, let's move it 3 places just to make it 304. Move this decimal 3 places, I get 1,000. So there are 304 children dependent on 1,000 workers. That at least makes it a little bit, you think, I have 1,000 workers, those 1,000 workers are supporting 300 children. Well, 304 children to be exact. Okay, so that's what these dependency ratios are about. They're talking about how much these workers are supporting. All right, next one. Let's calculate the ratio of 65 and over, so 65 and over to the total population. And hopefully you're like, ooh, that's a total. That's part to whole. I can write that as a percent. And that's what you kind of want your head to start thinking. When you start thinking things, seeing ratios that are part to whole, you want to think percent right away. So 65 and over, that gives me 39,178 over 306,110. I changed that to a decimal, 0.128. I did that by dividing, top divided by bottom. I moved my decimal 2 places, and I have 12.8%. So when I interpret the meeting, 12.8% of the population is 65 and over. I love part-to-whole ratios. I think they're very easy to play with. And that leads us to the old age dependency ratio. So old age, hopefully you think, oh, old age, that's 65 and over. Those are the old people. And if it's a dependency ratio, we're comparing it to the workers. So 65 and over compared to the 16 to 64. So if we find this ratio, again, 65 and over, we just had that number, 39,178, compared to the 204,777. And hopefully, again, your brain knocks on you and says, hey, 65 and over is part, the workers are part. This is a part-to-part ratio. I can only write this as a decimal. So when I divide top divided by bottom, I get 0.191. And when I put that over 1, I have the old people on top, the workers on the bottom. And as I did in the last problem, if I want to move that 3 places over, I get 191 over 1,000. So we've got 2 sentences here. We've got 0.191 oldies dependent on each worker. And I'm abbreviating because I'm in tough space here. Or we could say 191 oldies dependent on 1,000 workers. Kind of depends on how you like it. Some people prefer to see concrete numbers instead of decimals. That's kind of up to you. All right, let's go to the next one. Calculate the ratio of 15 to 64. Those are the workers. So we're using 15 to 64 to the total population. And again, fireworks going off in your head. Part to whole. That's a percent because you have the total on the bottom. So I've got the 204,777 over the total 306,110. I'm going to divide those to get a decimal, and because it is part to whole, I can make this a percent. So when I interpret this ratio, 66.9% of the population is in the working class. Or you could say is 15 to 64. Just because people are in the working class doesn't mean they're working, am I right? I'm right, right? For a whole host of reasons, right? Not any one better or worse than the other. But generally we call that the working class, 15 to 64. Okay? All right, so let's look. And we all know there are plenty of people older than 64 who are working, right? My dad being one of them. Okay, so let's look at number 9 here. We've got the age dependency ratio. Now, when you just see age is talking about all dependents. Well, all dependents are the under 15 and the 65 and over compared to the working class. We've got to put both of those dependents on the top. So I'm going to take the 62,155 of my kids, and I'm going to add the 39,178 of my oldies and compare to my workers. Now that gives me 101,333 divided by 204,777. And think about this. these are two parts, but that is still part. The workers are part. This is a part to part. We have a decimal answer here. So I end up with 0.495. So I can make 0.49, gosh darn it, jack that up there, didn't I? So 0.495 over 1, or I could make 495 out of 1,000. Okay, or you can even round that to 0.5. So interpreting that ratio, 0.495 dependence on each worker, or 495 dependence on 1,000 workers. And these workers are also supporting themselves, by the way, because notice nobody is supporting them. Now, in thinking about this, if we've got a 0.495 dependency ratio, it means every worker you're supporting yourself, you're supporting half of another person. I don't know about you, but I'm pretty stingy. I'd rather just support myself. So which is more economically desirable, high or low? Well, low, because if you think about it, the less you have to support somebody else, financially, the more money you have freed up to do other things. You know, that's why people who don't have kids, they travel more, they spend more, because they're not paying for the money-sucking kids, right? Kids are great, love them, they're expensive, right? So a low age dependency ratio allows for more money to be moving freely in the economy, which would help everything. All right, we've got one more piece of this, and that is to look at this here graph. So you can see this line here is approximately where 2011 is, which is the data that we just looked at. Okay, so these are the three pieces that we just looked at. And we're going to answer some questions based off this graph. So 1 and 2 we're going to do together first. Horizontal and vertical axis. All right, so horizontal and vertical axis. So if I go back, horizontal's down here, and that is years. Here's the vertical. And the nice thing is, usually the axes are labeled. Look at them. Look at the title. Look at the axes. Right? So per 100 persons of working age. So this thing, this number where you look and it's right around 20. That'd be 20 over 100. That's what this is referring to. All right. So horizontal axis is years. Vertical axis, number of dependents per 100 persons of working age, right? That's just written right on the vertical axis. Okay, now, does the graphic appear to be consistent with the ratios calculated? Okay, so let's first pull off the graphic, and then we'll use the ones that we calculated. So we're looking at child, old, and age. So, child, that's the solid that's here. Well, I got a mess. So the child appears, if I go this way, I don't know, I'm going to call it 42. This one is old people. We already said that's around 20. And then age, I don't know, it looks to be maybe 68. Okay, so I'm going to go back and do those. So 42, 20, and 68. So the child was approximately 42 over 100, which gives me 0.42. Old age was around 20 over 100, which gives me 0.2. And the age dependency was approximately 68, which is about 0.68. Now, if you think about what we just calculated, we calculated child at 0.304, old age at 0.191, and age dependency at 0.495. So you can see these two are pretty close, but the other ones are quite a bit different. And why is that? I don't have any idea. Don't ask me. I don't know. Okay? So that is different. It is different. But I guess they're in the ballpark, but they do appear to be pretty different. Now, what is happening in the baby boomers time period and the long-term prediction? So let's go back. So baby boomers is here. So you can see all dependence increases greatly, as does the old people dependence. And that makes sense. When all the baby boomers retire, we are going to have a lot more old people to support, while the children are staying constant, right? It seems like people are still having kids, but we are not increasing the number that we're having kids. And then over time, you will see how the old people and the kids are going to kind of almost come together and be equal, while the overall dependence continues to kind of increase there at a small rate. And that kind of answers the questions dealing with this age dependency ratio table.